All right, let's go through this problem. You are simplifying or evaluating the logs. I told you guys you can use a box. Again, you're not using a variable because we're not kind of like solving for a variable, but there's your box. Class, what's your base? You can also write it on the exponential statement on the right side. Reason why, it just kind of gives us a standard way of working. Put your finger on the base. There it is. We're going to switch those now. 27, and then my box. What you could do is, some of you are guessing numbers. Raise your hand if you do that. It's totally fine. It's okay. But you can also think about changing this into what? Base and exponents. Here's your hint. What do you think that'll become? What's your base? 3. And then to what power? And then you can see same base, then this has to be equal, right? That means your box has to be what? 3. Because if I put a 3 in there, that's 3 to the third power equals 3 to the third power. So our answer is log base 3 of 27 equals 3. Raise your hand if you got that. Let's try some more. Make it a box. Put the box on the left, or the log statement on the right. Class, what is my base?
4.
So 4 is small, now becomes big. And then what are we going to do? Everyone say switch. Again, I've noticed the students who always do the inverses with arrows are super helpful. Think back to chapter 1. So class, what do I write over here? Box. Tell your partner what this turns into. Does anyone think of a number? 1 over 2? Let's think about that. Okay, I'm going to change. This is really 2 over 1. Yes?
Yes.
This one is what? 2 to the power of 2 with the box. Two, 4 is 2 squared. Okay. 2 times, and if you need to do a side problem, you can. 2 times a box equals what number?
4.
Equals 1. And if you need to solve for the box, you can just use divided by 2. If you're confused with the box, you can use a variable x or y. But I just want to make sure you're not solving. The box is equal to what? 1/2. 1/2. And you might be asking, how does 4 to the 1/2 power, did we talk about fractional exponents? Yes or no? Why does that work to equal 2? So 4 to the 1 over 2. This 4 to the first power, that's the numerator, and the index of a radical sign is your denominator. So 4 to the 1/2 power, that's meant to show, that's 4 to the 1/2 power. 4 to the 1/2 power is the same thing as 4 to the 1 power, and then you take the square root with the index 2. Class, what is the square root of 4? 2. Okay, so if this has been a far stretch for you, what's happening is there's a lot of math. There's exponents, that's the prior math, and also fractional exponents. Let's try the third one. Class, what's your base? 10. So let's write 10 really big. Switch them. What goes on the left? 100. The box is equal to 2. Remember, you can just change that one into 10 squared, right? Does that make sense? So 2 goes in there. Let's try this one. Boys, what's your base?
2.
What goes on the left?
2.
And what's its exponent?
1.
Box is equal to 1. Right? Box is equal to 1, so put a 1 right there. Girls, what's your base? Girls, what goes on the left side? And what goes up there? Box is equal to 0. Anything to the 0 power equals 1. So 5 examples of us simplifying or evaluating logs.